Hi everyone, welcome to Cobalt Academia's Hacking How to video series. I'm Busra, aka RU1R0, an offensive security researcher and a pentest architect at Cobalt.io. With Hacking How to video series, we see how to exploit vulnerabilities that we encounter every day during pentests. In this specific video, we will see how to exploit deserialization attacks by using different scenarios. If you're ready, let's jump in. Hi everyone, in this video we will see how to exploit Java deserialization by using PortSwigger's lab. So we will be using the specific example exploiting Java deserialization with Apache Commons, and we already know some information about the serialization here. So let's read the description. This lab uses a serialization-based session mechanism and loads the following: Apache Commons collection library. So this is the one that we're supposed to know because we will be using the predefined, pre-built gadget chains because we don't have access to the source code. So in the other examples for other technologies, I showed how to read the source code and create your payload, create your exploit according to it. In this example, we can think of this as a white box test, and we know which library is in use. Maybe we got this via an error message, or we got this information somehow. Okay, so in order to do that, we will use a really common third-party tool called Serial to get a remote code execution to delete a file from Carlos's home directory. So I already logged in with the given credentials in here, and when I send this to burp, so we get this request. I'm sending this to repeater, and thanks to burp's new feature, we can just see the automatically decoded value is in here. So we have the following value in here. Since I'm aware that which library is in use, I just installed the tool Serial in my Kali box, and I wrote the following exploit to create a payload for myself, which is in the syntax. I'm using Java -jar to call the file Serials. Then I will be using the common collections for library which is in use that I'm aware of. Then I will be writing my comment. Then I will be encoding this with base64. I'm also adding this as an addition because I don't want to add new lines. So when I run this, it will give me a base64 encoded value, as you can see in here. So what I will do is I will be copying the selection, will go back to burp repeater, and basically I will be replacing my value with the following by URL encoding this value as it was in this way in the previous example. In the previous way, when I send this, it will give me as lab is solved. I can also send this in repeater. I will also send this in browser to see that the lab is solved as here. So this was a quick example on Java deserialization attack, but if you don't have access to the source code and you're aware of the library in use, what you can do for Java deserialization attack is using this really common tool Serial to create your base64 encoded value or whatever encoding you want to use to get a reverse shell or do some remote code execution. In this video, we will see how to exploit JSON.NET deserialization attacks by using a hacked box machine called JSON. So I already done some basic enumeration, and I found a login page, logged in with default credentials admin. When I intercepted the request with burp, I observed the following. As you can see, there is a base64 encoded bearer and cookie value, which are basically the same. What I've done here is that I send this to decoder to see what kind of value do we have. As you can see, we have the following: username, user role, and stuff. So what I've done is I cleared this bearer header value and sent a request. As you can see, we get the following null value. So instead of writing the same value as the cookie, I just wrote here a random value, which is base64 encoded. When I send this, I get an error message by saying cannot deserialize JSON.NET object. So at that point, I love error messages because they generally give us juicy information about the underlying technology. So I just checked for these keywords to find a deserialization attack, and luckily I found one. So what I've used is I used Deserial.net payload to create some attack value. So I used this exe file on my Windows machine to create some attack payloads. So the first thing I did is I wanted to ping my own attacker machine using the target machine by using this exe file. So first I create the payload, I copy this value, I go back to burp and send the bearer value with the following. But I like to see what kind of impact do I have. So basically I just started listening with TCP dump to see if anything is coming, which is happening. As you can see, I am getting ICMP requests here. So at that point I realized that I can just communicate with the target machine, and my next step was downloading Nishang PowerShell scripts as the following. I used invoke PowerShell TCP.ps1 and included my IP address and port number that I will be listening on at the end of the script as the following. If you don't know how to use this script, you can just go on the top of the script to see what kind of examples that you can use. So basically I'm using the reverse shell one. I'm listening on port 8000 to get the file in my current working directory, and I'm also listening on port 1234 to get a reverse shell. And this is the next payload that I will use. Basically I will be using PowerShell exit to download a file from Python simple HTTP server default port 8000 to download info PowerShell TCP file to get a reverse shell on the target machine. I will be copying this. I will paste this value for bearer, and I'm hoping to see that the file is being called and get a reverse shell immediately. As you can see, the file is being called and we get the reverse shell as who am I? JSON user pool. So I think this is a really cool scenario. If you see that JSON.net error message, you should probably check Deserial.net exit to see if you can create your payload and communicate with the machine, if you can upload a file and get a reverse shell finally at the end of the box. In this video, we will see how to exploit Node.js deserialization attack on a hack-the-box machine called Celestial. I've already done some basic enumeration, and if you're ready, let's jump in. I've done basic port scan, and I realized that port 3000 is open, which uses Node.js. So from there, I know that Node.js is vulnerable to some deserialization attacks, and I am keeping this in my mind while I'm doing the pen test. So at that point, what I've done is I basically went to 3000 port, and it gave me the following message. What I've done is I intercepted the request with burp and sent it to repeater. As you can see, we have a cookie value which is base64 encoded. What I've done here is that I've sent this to decoder and decoded it with base64. And I saw the following: username dummy, country I don't know, probably somewhere dumb, city lame town, and number is the following. Let me hit the following. Yeah, let's close this. Perfect. So what I've done here is that first I changed this value to another numerical one. I again encoded this with base64, copied this, went to repeater and replace it. When I sent this, I saw that the number is changing as 5. So I have control over this value. The next thing I've done is I just added some string value without quotation to see some error messages about the underlying technology. So I encoded this again. I'm not sure if it changed. Okay, let's copy this and paste this again. When we do this, we get an error message. These Node.js modules are under the home directory of some. So I've done some research on how to exploit Node.js deserialization attacks, and I found the following really cool research on this website. It's really cool, and I got the idea from this payload basically. As you can see, there's a function defined in here which basically gives us how to compose to exploit payload for Node.js deserialization attack. So what I've done the following. So as you already saw in the decoded version of cookie value, we have this following structure. So we changed this value and we saw that we have control over this. So what I've done is I basically changed username because I know that there is a user called Sun, and Node.js code is what I've done is I changed this username value with the following based on this research. So if you go there and see this value in here, I wrote ndfunc function record child process, and then instead of exec ls, I wrote my one-liner for reverse shell by writing my IP address and port number. Let me state it in here until the single quotation mark closes. And then I basically just used the rest of it. So what I've done is basically I use this as the payload, as the value for username, as you can see here. So I copied this, go back to the box, and I went back to burp. I will be listening on the port 1, 2, 3, 4 again, and we'll be changing this value. Oh, sorry. First I need to encode it. Let me write this and encode as base 64. Copy this, and on the repeater, I will be replacing this value to get a reverse shell as Sun. It's pretty cool. It's really important to do meaningful research to see what kind of payload you can use, and I really enjoyed this article here. Thank you to the author. And as you can see, you just need to play around a bit to see which kind of value you have control on, which kind of value you can change, and which kind of payload you can use to exploit the vulnerability on Node.js deserialization. In this video, we will see how to exploit deserialization attacks in PHP by using PortSwigger's lab. So I included this specific example, arbitrary object injection in PHP, which explains the deserialization attacks very cool in PHP. And if we're ready, let's jump in. So I already fired up the lab and I already logged in. And what I will do is I will be intercepting the request and we'll check it out, and we'll check the session cookie. I'm sending this to repeater and send the request again. And at the end of this code, you will see a comment, an HTML comment saying that refactor once, and it's given us a PHP code. I want to see the PHP code to understand what kind of code we are dealing with. When I send it like this, it's not giving me the code content. So I will be adding this special character to get the backup code, which gives me the PHP file content. So let's read this PHP code now to understand what kind of code we are dealing with here. So as you can see in the custom code, we are dealing with custom template class, which contains the destruct function. This destruct function, which will invoke unlink method on the log file path attribute, which will delete this file on the path. So what I need to do is that I need to decode the session cookie, which is base 64 and URL encoded value. And as you can see, we have a meaningful structure here. So what I will do is I will just be copying this and sending this to decoder. Okay, we don't need to play around it a bit. So what we will do is I will be changing the values. So let me do this. Oops. And basically I will be pasting this and play it around. So in here, instead of user, I will be using custom template class. So if you check how many characters are there, it should be 14. Let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, that's correct. So as you can see, this number 2 indicates that there are two match, like username value winner and an access token value this. And these numbers are S indicates the number of characters in the values in here. So what I want to include here is the following log file path attribute. So I will be copying this attribute and we'll go back to decoder to change this value to log file path. So according to the exercise, we need to remove a file, moral.txt, from Carlos's home directory. So I will just go back, and instead of this value, I will say home Carlos and then moral.txt file. The rest of it is not important, as I am not including the second value. So instead of 2, I will be including 1, since I'm only dealing with one attribute here. So of course I need to also change these values, as number of character is different in this case, which should be 23 here and 14 here, if I'm not mistaken. I am removing this, and the first thing I will do is encode this as base 64. I will be copying this value, going back to repeater. I'm not including this URL encoded value, as it will be the same. I will be pasting this and we'll send it, of course not with this, but with the root file, and you will get the exercise solved. Congratulations, you solved the lab. So what we've done here is that we sent this cookie session value, and we needed to see the source code so that we can deserialize the object and play around a bit. So we realized that the first one was user attribute and values according to it, which is user value, username value, and token value. But we needed to change this to another attribute from custom template class with log file path, because we read the code and we saw that log file path attribute is associated with deleting files, removing files, which is our goal here. In this video, we will see how to exploit Python pickle deserialization attack on a hack-the-box machine called DevOps. If you watch my previous videos on execz, you will realize that I already included a solution for this box on execz attack, but I will show you how to exploit deserialization as an alternative method for this box. So, if you're ready, let's jump in. If you've done some basic enumeration as I've done, you will realize that there is a 5000 port open, which allows us to go to this upload file. It allows us to upload XML files with the following content, and we already get execz. So we already reach out to internal files, as you can see, by using a really simple execz payload. So if you realize in the beginning, when you were doing your enumeration, in the index page, you can see that there's a file called feed.py. So what I've done here is that I just read the file contents, since I can, using execz vulnerability in here. So when I read the code, I realize that when you are sending a post request on /new post, pickle module of Python is in use. So if you're not familiar with pickle module of Python, I can just give you a quick introduction. So the pickle module implements binary protocols, serializing and deserializing a Python object structure. If you check online for security implementations, you will see that the pickle module is not secure, because it allows us to do deserialization attacks. So that's exactly what I will use in this scenario. I checked online and found a really basic pickle Python deserialization code, which gives us the following really small and neat one. I wrote my own IP address and the port number that I'd like to listen for reverse shell, as you can see here. So what I will do is the following. First, I will run this code, and it will give me the following encoded base 64 encoded value. I will be copying this, and if we read again, we need to send a post request on /new post, and we need to include our base 64 encoded value in here. So what I will do is I will be sending this repeater. I don't need this content in the body. I will be including my base64 encoded value here. Content type should be text only. You can just modify this yourself. These can be deleted. Refer is not supposed to be with upload. You can just keep it as it is. I can delete the followings as content type is already specified here. When I send on new post, I am immediately getting a reverse shell as USA. So pretty easy bugs. So it's pretty basic. Like I said, when you see pickle, you should understand that pickle module of Python is in use, which is not a safe module to use because it allows deserialization attacks as we conducted here by combining exec vulnerability. Thank you for watching my videos. Stay tuned for more content. Cheers!